is right here. We will be testing Friday. So look at your partner and say, hey, we will be testing on Friday. Now, if we have a test on Friday, that means something is due on Friday. Do you remember what that might be? Your, your lab book. All right. So in your lab book, the homework starts on page 12, I believe. Now, we have done and will do a lot of them together, but not all of them. If we don't do them together, that does not mean that they're not assigned. That means they are literally homework instead of school practice problems. So make sure if you have some that are not done that you fill those in. Okay, the test, just to get you ready, you can find this information on the front of your lab book. These are the things you'll be tested on. And this test is the hardest test of the year. All right, the next two tests are simple compared. The previous test was kind of hard. It was the second hardest. This is the hardest. This part's easy. It's naming the 6 evidences of a chemical reaction and then some application of that. Reaction types, these are really easy. We already took that quiz. It took a minute and a half average. So that's not bad. Matching terms, I think these are easy because I give you a QR code on the front cover so you can study those for weeks and weeks and have them memorized. All right, I think these are of medium difficulty. These are hard. These are hard. These are easy. You haven't learned them yet. Whoops. I guess that's the third letter. All right. Medium and medium. So, well, hello. That's kind of the setup of the test. These two that are hard, the cutoff is 60%. If you get above 60%, you get 100%. So there is a large parachute to help you survive this jumping out of the plane. If it doesn't open, you're screwed. But that's you neglecting to pull the ripcord, which means studying. David, you need to go to P3 right now. I have no idea why, but we'll miss you for a minute. Probably not. Yes, sir. Oh, it didn't take very long for you to call me out on it. Okay, Zoom recording. So anyway, start studying. You probably haven't even looked at these, but you should. You should study these. You should study these, and we'll go for it. Today, our main goal is to get C and B locked in so that we can do well. Okay, so if you'll just turn to your homework, have your naming schemata handy, also have your periodic tables handy. We're going to do these problems. Now, I know that these are somewhat difficult. I know that you'll never do them any time in your life unless you're a chemistry major. Or, look, in college, you'll take a lot of chemistry if you want to be a chemist, obviously, be some sort of engineer, be anything in medicine. That could be from a dental hygienist to a surgeon, a drug dealer. You definitely need to know your chemistry. Well, if you're a drug maker, dealers, they just collect and distribute. But if you're going to cook meth, you better know chemistry. Practice safe chemical hygiene practices. Anyway, doctors, all that stuff. Dentists go to more chemistry than almost anyone. So anyway, yeah, they take a ton. Well, hey, or Reardon, you're a genius. Don't stress about it. All right. All right. So this this is good exercise for your brain. That's why we do it. We're solving multi-step problems. All right, if you look at this naming schemata or the picture on the right that's bigger, I changed it a slight bit. I covered up the products. Do you notice that they're blank? Now, you don't need to do that on yours, but I did that because then it kind of helps us see how to do problems 21 through whatever the problem is. I don't remember. Um, so the first step, when we are going to complete a chemical reaction, when we're just given the reactants, we need to do the following. We need to use the naming schemata to determine types of reactions. So that's this box. Next, we follow the rules to find the products. For this one and this one, it's a piece of cake. For this one and this one, it's a little bit tricky. So that's why there are rules. We can follow them, we'll be successful. Then balance the charges, which is the drop and swap. Then last, balance reaction by using coefficients. So it is a fairly large multi-step problem. Now, I think Friday we did a couple. Is that correct? Did we do 21 through 23, or did we just do 21 and 22? All right, so 23 is where we need to be, correct? Okay, so let's do it together. So I look at 23, and all it gives me is one reactant. If I look up here, I look at my models, that gives me two reactants. That gives me only one. That's probably the right answer, but I check. Here are two. Here are two. Here are two. So this has to be a decomposition reaction. It's the only option that it could be is a decomp. So I write that in front of number 23, decomposition reaction. Okay, the next thing, I need to follow the rules of decomposition. Now, to know which rule to follow, I need to know what the anion is. I need to know the name of this thing, which I can find on the front of the naming schemata. Find ClO4 for me. All right, it's per technically, but it doesn't really matter. Oh my gosh, matter. You know what else? Go to speech therapy in second, third, and fourth grade, and then you're still 45 and you hit that once in a while. Yeah. Oh, just me? Okay. Speech therapy's a thing. Okay, thank you. Hey, it's more common than you think. You sat in second grade and a couple people left every day. They're like, oh, they're going to go have fun. But no, they're like, truck. You're like, ah, I can't say that word. Anyway, moving on. It wasn't that bad, but it was, anyway, I'll shut up. All right, perchlorate. So I need to know this piece in order to know this rule. If you look at letter C, do you see letter C? Metallic chlorates, when heated, decompose to metallic chlorides. So that means I take the metal and then I put chlorine next to it. Now, I'm going to write the rest before I balance. And oxygen. And hopefully by now you're familiar that oxygen is diatomic, so you put O2. Okay, so I followed the rules to find the products. Next, I need to balance the charges. So I need to know what the formula of this is. I put the two pieces together, and Ethan, you said it was what? All right, there's a 4 right here. How did you know that? What's that? All right, because this 4 right here tells me Mn is a +4, or that it has to have 4 of what it's with. All right, now that one's sort of tricky, but now we're ready to roll. Our final step, once we've balanced charges, is to balance the reaction by using coefficients. So will you try and balance this reaction using coefficients? Okay, definitely the wrong thing to do. That was supposed to be that. Okay, so try and balance it. You're good. All right. Do we have it balanced? I do not. Did they announce it? I think it might be whoever's with me. I think it's, I have no idea. That's something that I was told in a faculty meeting, and most likely I was not paying attention at that moment in time. But TBH. All right. So if you have it balanced, check with your partner, 10 seconds, check with them. All right. All we need is an 8 right here. Is that correct? So 4 times 4 is how many oxygens? 16. So I need to make 8 times 2 to get 16 of them. Everything else was balanced. 118. Who had that right? Raise your hands. What did you girls have? Okay. Pretty common. All right. Next is number 24. All right. So it is a single replacement reaction. If you look at 24, it has a lone element and then a compound. When you check the models, you'll notice single replacement has a lone element and a compound. All right, single replacements have their own rules, but they're really pretty simple almost every time. You just take the front thing and you switch it. Now, there's a rule to this, but just watch for a second. You can always do the following. If the first thing's a metal, it will always replace the first part of the compound. If the first or lone element is a nonmetal, it would replace the back or the nonmetal. We will 99% of the time take the front pieces and just swap places. All right, so this is replacement of a metal in a compound by a more active metal. This is rule A. So aluminum now hangs out with who? NO3. Now I'm going to leave that as is for a second. And who's the new lone element? Cu. All right. Now I need to balance my charges. So I'm going to need my naming schemata because I need to know the charge of aluminum and the charge of nitrate. Aluminum we can find on the naming schemata or the periodic table. What's the charge of aluminum? +3. What's the charge of nitrate? From your naming schemata, it is a front page, left side, -1. So aluminum nitrate is really AlNO3, 3, and then Cu. Is copper a diatomic atom? No, it's not. So it's just left that way. Okay, then you're ready to balance. Will you try to balance? If you've been keeping up with my fantasy football season, and I was terrible the whole time, you may remember if you had me for first hour, I would like to report that I am 0-4 in fantasy basketball as well.
Hey, you're doing just
So-
good as us in basketball. You look both.
It's my year. Okay, thank you. It is definitely, wow, it's a struggle this year. There's always fantasy baseball. Whew, we'll see. All right, here we go. Let's balance this. So it's not a single element, but I still see a 3 and a 2. Did anyone notice that? So I put a 2 in front of the 3, sorry, a 3 in front of the 2 and a 2 in front of the 3. Then I just need to fix both metals. That made 2 aluminums. That made 3 coppers. 2, 3, 2, 3. Who had that? Thumbs up. Okay. Not too bad. They just take time. I don't think these are as hard as 11 through 20, but they still take some time. All right, we're going to be on 25. 25, will you try that on your very own? I will give you 3 minutes. Or as long as it takes me to figure out how to get the right timer. There we go. Let me guess, you want to go to the bathroom? Yeah. Okay, be back in 2 minutes this time, not 15. Check with your partner that you both got the same type of reaction. All right, here we go. My watch says we're done. So I walked around and about half had it. A quarter didn't try it, and the other quarter was a little bit confused. All right, looking over here on that screen, we have a single element and a compound. that is a single replacement reaction. The model T plus RS is representing a single element plus at least two elements. It could be more. There we go. So a single element plus a compound. According to our naming schemata, and we don't have to do this part, but you can see that it follows rule B because I have water and a metal. So I look over here and I follow the same rules. I take the first element and I switch it with the first element. So I end up that Na is now hanging out with a new friend. It's whoever H was with, so it's hanging out with OH. Plus, I have a new lone element, and that was that I took the H off the front. But I should double check, is H diatomic? Yes, it is. The next step would be to drop and swap or balance charges. I find on my periodic table that Na is a +1. I find on my naming schemata, hydroxide is a -1. So I do not need numbers there. So that means I am ready to balance. All right, give that your best balancing shot. All right, I'm going to wrap it up here. I have two H's. So I'm going to make two H's. Because remember, this part is an OH. Okay, now that makes two OH's. So I need to put a 2 here. That makes two sodiums. So I need to put a 2 here. And then I'm back to where I started. So I put a 1. 2, 2, 2, 1. Okay. Number 26, I don't have any of these on the test. A lot of kids get them wrong. 26 really looks like it's a single replacement reaction, but it is not. If you would look, we need to be real careful. A single replacement is a compound and a single element, but this bottom part, a combustion reaction, when we have something that's CH plus O2, it's a combustion reaction. And you would have this part on your periodic table or your naming schemata. It would tell you it makes CO2 plus H2O. Now, I don't have one of those on the test in this section because too many people mark it as single replacement and it messes up their lives. So we have CO2 plus H2O. I don't need to drop and swap. It tells me just straight out, those are my products. Balancing this one, this is a combustion reaction. There were 4 tips on page 12 on how to balance a combustion reaction. The first one says to start with a 2. Well, you do the rest from there. Take about a minute. When you're done, check with your partner. Number 26. If you're good and you move on without me right now, I am just fine with that. Did you get it?
Yeah, look.
Okay. Okay. If you follow the steps, it at least gives you 3/4 of the answers. So step 1 says start with a 2. That's why I put a 2 out in front. Step 2 says balance the carbons. So 2 times 3 puts us 6. Step number 3 says take the number with H and put it in front of water. So that's an 8. Step 4 says balance the oxygens. We have to account for them in both places. So 6 times 2 is 12, plus 8 times 1 is 8. That equals 20. But it will be doubled, so I have to take half of 20 and put a 10. Now, if anybody puts 1, 5, 3, 4, you are also correct. If it can be reduced, both answers are correct on the test. All right, how do we feel about that? Let's look at 27. If I were to look at 27, I see there's no single element and no single element. That only matches what model? A double replacement. In a double replacement, I have 2 elements plus 2 elements make 2 elements plus 2 elements, right? Or compound plus compound makes different compound plus different compound. So these are not bad. I would advise you to just do the following. Always put a line right after the first thing. Like just the first element. Don't go to the middle. That'll really screw you up because chemistry doesn't work that way. Now, there's only one exception, and I don't have one of these on the test either. There's only one exception where the first thing is more than one thing, and that's if we had NH4. Like let's say it was NH4 and C2H3O2. This one you would split there. It's the only exception, and that's because NH4 is the only positive polyatomic ion. There's not one of those on the test. So the first, just draw a line and then switch them. So I'll take Cu and put it here. And it's now hanging out with hydrogen's partner, C2H3O2. Then I'll put H right here, and it's hanging out with copper's previous partner. I'm going to put an OH. Now, I did not balance charges yet. I just put the things together. The next step is to balance the charges. Copper, we have to do this once in a while. Copper's charge can be like seen right here. It's a +2. That's why there's a 2 right here. We know the drop and swap. There's no reason why I can't hop and swap. All right, so a +2. I can look on my naming schematic and find hydroxide is a -1. So a -1, and I know water is just HOH, so I'm not going to mess with that one. So all I'm left with is to balance this. So I need a parenthesis and a 2 on the outside. Okay, now balance. Yes, sir. That is combustion, yes. I like it neat too. Oh man. Okay, to balance, I need 2 of the acetates. So I'm going to put a 2 right here. That makes 2 H's. So I put a 2 in front of water. That makes 2 H's, but also 2 OH's. And bingo, I have 2 OH's. So 1, 2, 1, 2. Thumbs up if you had that right. Okay. I'll do 28 with you, and then I'm going to let you have a few minutes to do some on your own. First off, look at it and tell your partner what type of reaction 28 has to be. There's only one option. It has to be a decomp. In my opinion, these are the hardest ones. So it's a decomposition. The next thing I need to know then is the name of this part. OH, anyone know the name of that? Hydroxide. I need to know the name of that because once I know the name of that, it can tell me which rule I follow. Do I follow carbonate? No. Do I follow hydroxide? Yes. If you would like to, well, I'll leave those there actually. If you would like to, you can write carbonate is CO3. You can write hydroxide as OH minus. You can put chlorate is ClO3 or ClO4. And acids and oxides, those are just acids or oxides. If you want, you can put that. So when we see that hydroxide, this looks like a C right here, but it's an arrow. We see OH, we're going to follow this rule. A metallic hydroxide, when heated, decomposes into a metallic oxide and water. So I'm going to go back. That means I take the metal and it's with oxygen. That's what an oxide means. And water is H2O or HOH. Then the next step is to find the actual formula of Al and O. We've done it like 10 times. Aluminum is a +3, O is a -2. So Al2O3. Now, this one actually, it can get you, it's tricky. When in doubt, start with the metal. The metal it'll help you get the things right. So if you have 2 aluminums, you know you needed 2 in front of aluminum. Now, that makes 6 hydroxides. And the problem is the hydroxides break up here. So we need to separate them. It means we have 6 oxygen and 6 hydrogen. All right, I have 3 oxygens already, so I'm going to put a 3 right here. That also makes 6 hydrogens. So then I'm actually done. 2, 1, 3. That one's typically a really hard one. Okay. Will you, I don't know, we got 9 minutes. See how many of these you can work through in the next 9 minutes. Work with your lab partner. Oh, hey, 1 second. Number 35 is a single replacement reaction. Will you please notice, though, it's the only one we've done where this piece is a non-metal. So on the right side, this time, a non-metal will replace the other non-metal. It was like, in my analogy of me, Andy, and Shannon, it would be a little bit different. It would be that while Shannon was on vacation, I found a different girlfriend. All right, so over here we have AU and CL, and now I2 is by itself. This is a +3, this is a -1, so it's AuCl3. Okay, I did 90% of that for you. Okay, hop on it, see how many you can get. Tomorrow I'll give you a stamp if you have all of 29 through 35 done. Well, all of whatever, 21 through 35, I think, but we did most of them together. So, okay, I'm gonna stop the recording here.